Okay, ladies, here's a few review problems from sections 1 through 5. It'd be really good to do this before the quiz. And what you need to do is right now pause it, write down those two problems, and then answer it. And when you have them both answered, then press play. Okay, so you need to pause it now. Okay, 8 less than the product. So 8 less. Okay, you should already have the answers written down. So 8 less means you're taking away 8, and the product means to multiply 6 times a number. You cannot write that as 8 minus 6a because subtraction is not commutative. Second one, 20 plus the quotient of 7 and x. So 20 plus means you're adding 20. Quotient means you divide the quotient of 7 and x. Since it is addition, it is commutative. So you could switch around the order. Okay, now in these 6 problems right now, you need to pause it, complete all 6 problems before you press play again to see if you're right. Okay, so pause it now. Okay, simplify as order of operation. Okay, I'm going to work inside the parentheses first. So you get 3 plus 16. So my parentheses gives me 19. And then I bring everything down. Remember, this is 5 times the parentheses. So I have 16 plus 5 times 19. I do multiplication first. 5 times 19 is going to be 95. Okay? Then when I add the 16 to the 95, again, if you have to ever do your work, just do it over on the side. 11 carry the 1. You end up with 111. Same thing if you were doing the work for 19 times 5. Just do that work over on the side, because this really should be a total non-calculator item. Okay, absolute value, inside the absolute value signs first, so I'm going to add negative 3 and 8 and get 5, and then the absolute value of 5 is 5. So do not take absolute value individually, so you work inside the grouping symbols first. Order of operations, parentheses first. Again, if I'm going too fast with the answers, you guys can pause it at any time. Multiply, and then you add. I'm going to do the grouping symbols first. 3 plus 8 gives you 11. Okay, on this one, I'm going to write it as an addition problem. So 2 negatives make for a positive. I'm going to find the LCD of 9. The first fraction I don't need to change. The second fraction I need to multiply by the denominator by 3, so I have to multiply the numerator by 3. So I get 3/9. And then my denominator stays the same. I add the numerators, I take the sign of the higher and subtract the numbers. Now on this one, again, anytime there's a subtraction, I'm going to change it to addition. I'm now adding 2 numbers with the same sign. I keep the sign and add the numbers. Okay, write down this problem. Pause my video, answer it on your own, and then come back. Okay, you should have the answer now from least to greatest. Since I have a negative one there, I already know that negative 8/9 is the least. So I'm already done with that one. So I'm really just comparing 3/4 and 5/7. So if I find the LCD of each of these and change it, the LCD happens to be 28. So if I want this to have a denominator of 28, I would have to multiply it by 7 over 7. Get 21/28. If I want this to have a denominator of 28 so I can compare them, I'd have to multiply it by 4 over 4, and I get 20/28. Well, which one is smaller? Well, the 20/28, which is the 5/7, so 5/7 is going to come next, followed by the greatest of 3/4. Okay, and the next couple of problems are to name the sets of numbers, write down the problems, and then pause it to come back for the answer. Okay? Alright, so first thing I'm going to do is see if they're rational or irrational. So if any of them are irrational, this one's irrational, so I'm done with that. Pi is irrational. Square root of 15 is irrational. So if they're irrational, I'm finished. Now, the rest of these are all rational because they can be written as a quotient of 2 integers. Now, what we're going to do is look at the subset. The subset of that would be to see if they're integers. Okay? Well, negative 0.7 is not an integer, so I'm done there. Okay, remember I said I was done with the irrational ones. All right, 3/5. It's not an integer. Remember, integers are 0, 1, 2, 3, 4, 5, and so on. -1, -2, -3. I'm done. 0 is definitely an integer. Okay? Now remember, square root of 25 is technically 5. That happens to be an integer. Okay, so I'm not done with these two. Let's go back to the subset of integers would be whole numbers. Is 0 a whole number? Yes. Is 5 a whole number? Yes. Let's see if we're finished. A subset of whole numbers is a set of natural, also known as counting numbers. Counting numbers are 1, 2, 3, 4, 5, 6, and so on. 0 is not a natural number. So I was done there. Is 5 a natural number? Yes. Okay? Do lots more examples, and good luck.